In Chapter 9, we turn our attention to hypothesis testing. Okay, this is the primary component of what we call inferential statistics. Chapter 8, we introduce confidence intervals, which are the first part of inferential. And then in Chapter 9, we introduce the idea of hypothesis testing. So basically what's going on is in confidence intervals, we wanted to estimate a population parameter. Okay, maybe it was a mean, maybe it was a proportion. But one way or the other, we wanted to try to get a good feel for what the true value of the population parameter was without having to take an entire census. If we were talking about something really large, like the population of the United States or the population of China, to count every person would be prohibitively expensive and time-consuming, and it would just be hard to do without the resources of an entire government. So what this confidence interval idea gives us the ability to do is come up with a good estimate for the population mean or proportion without having to count everyone. In this chapter, we're going to make decisions about parameters. Okay, usually what this means is someone makes a claim saying something like, I believe that the mean value is greater than this, or the mean value is exactly this, or some statement like that. Okay, and what we do is we take a sample and we test whether or not that claim appears to be supported by the data or not supported by the data. So that's the difference. Confidence intervals, we're trying to estimate a parameter. In hypothesis testing, we're trying to make decisions about whether or not particular claims about parameters are true or false. So yeah, this is restating what I just said a moment ago. We're going to look at a claim. We're going to decide, does this claim appear to be supported by data or not? And again, what we call this decision-making process is hypothesis testing. So here are our steps. Okay, here's the way we're going to do this. We are going to set up two opposing hypotheses, two contradictory hypotheses. One of them will say something like the mean is less than 5, and then the next one will say the mean is greater than or equal to 5. Okay, two opposite statements. Then we will collect a sample, or perhaps look at sample data that's already been collected for the in the case of homework problems. And then we have to figure out what's the right distribution, and that's going to change based on whether we're doing a mean or a proportion. And then within means, just like in Chapter 8, if we know sigma, we'll do it one way. If we don't know sigma, we'll do it a different way. All right, but then we're going to take our sample data and we're going to perform calculations, kind of like what we did in Chapter 8, but these will be slightly different calculations. And then what we will do is decide whether or not the null hypothesis needs to be rejected or whether we should not reject it. And I'll explain more about that reject or decline to reject idea, because it seems like a weird way to say stuff, but I'll explain a little more in a minute. And then we make a decision about the original claim, and we write our conclusion in a way that references that original claim and makes sense in terms of that decision that we made. So in section 1, we're going to focus in just on identifying null and alternative hypotheses. Okay, this is the first step. I said in the previous slide there that the first step is to create two contradictory hypotheses, and so that is such an important idea that we dedicate a whole section to it. So our hypotheses are going to be these, okay, the null hypothesis and the alternative hypothesis. So we'll always have those two. Okay, and these are always going to be opposite of one another. Specifically, the null hypothesis states that there is no difference between the claimed mean and the sample mean or proportion. Okay, so in other words, the sample data that we got basically says that the claimed mean is exactly right. Okay, that's always going to be the null hypothesis. So the way we're going to be able to identify this is that the null hypothesis is always going to have some statement of equality in it. So that might be an equal sign, might be a less than or equal to, might be a greater than or equal to, but the null hypothesis always has some equality in it. The alternative hypothesis, which there's two different ways to write this symbol here. Notice that I have written H1. Your book, I think, uses HA. So on subsequent slides, I switched to HA. I just wanted to put this in here so that you know some texts, some authors prefer to write H1 instead of HA. But the alternative hypothesis is a statement that contradicts the null. So if the null says equals, then the alternative says not equals, and so on and so forth. So if we reject the null hypothesis in our final decision-making step, then what we're doing is we're assuming that the alternative hypothesis then is true. Okay, if we reject the null, then the alternative must be true, or at least must be supported. So after we look at the sample and we do our math, we can either reject the null hypothesis or we can decline to reject the null hypothesis. Some authors would say fail to reject or simply do not reject, but it's always phrased in these terms. Okay, we either reject the null or we don't reject the null. We reject or we fail to reject. And that seems like strange language, right? We'd either say, reject or accept or, something like that. But the specific wording of these conclusions, these decisions, is written specifically in such a way that it doesn't overstate what we're saying. All right? The decision to reject the null hypothesis is a clear decision that it appears the null hypothesis is wrong, we reject it. However, if there's not enough evidence to reject the null, that doesn't always mean that there's evidence to support the null hypothesis. It's just there's not enough to reject it. And that's a little bit different, okay? Usually maybe it's just me. Usually when I think of rejection, right, we think of relationships, or you ask somebody out on a date and they reject you. Well, think of it this way, okay? Reject the null is like a rejection. You ask somebody out, they say no, okay? Decline to reject is you ask somebody out and they don't say anything, right? They don't say yes, they don't say maybe, they don't say no, they don't say anything, okay? So at best, what you could say to perhaps comfort yourself is that, hey, she didn't reject me, and that's about the best you can do. So we have those two options, reject or decline to reject. So again, the null hypothesis, which is the H0, H sub 0, is always going to contain some kind of equality. Okay, it might just be an equal sign, plain and simple, or it might be greater than or equal to, or it could be less than or equal to. Whereas with the alternative hypothesis, we're never going to have equality. So it'll either be not equal to, or it'll be greater than, or it'll be less than. Typically in that first row where it says not equal or greater than or less than, in my experience, most of the time that is just going to be not equal. Okay, if the null hypothesis is equal, then the alternative will be not equal. It's not 100% true, which is why they put those other things in there. Sometimes there are cases where you want to use one or the other, greater than or less than. But in my experience and in the homework and things that you're going to work on, the quizzes, the final exam, you can count on if it's equals on the null, it should be not equals for the alternative. All right, so here's some examples, and I'm going to show you my preferred method for determining the null and the alternative hypothesis. It's actually a two-step process. The first thing I do is I read the statement and I try to write the claim in symbols and numbers. So this says no more than 30% of registered voters in Santa Clara County voted in the primary election. No more than 30% is less than or equal to 30%, right? And we're talking about a proportion here. This is talking about a percentage or a proportion of voters. So the symbol I'll use is P for proportion. And like I said, no more than 30% means less than or equal to 30%. So my claim statement written in symbols is P is less than or equal to 30%, or 0.3. And then I immediately write the opposite of that statement. Okay, so the opposite of less than or equal to is greater than. And you need to make sure that you remember that when we're talking about opposites or negations in math, we have to make sure that we're exactly including everything that is not in the original claim. So if the claim, for example, had just been less than, then our opposite would need to be greater than or equal to. If I just make it greater than, then I'm leaving out the possibility that it could be exactly equal to 0.3, and then that I would be missing out on some of the information. So got to make sure that the claim and the opposite are always exact mathematical opposites or negations of each other. Okay, so now from this step, I have written out one statement that contains equality and one statement that does not contain equality, and now I assign the one that has equality to the null, which is H0, and the one that does not have equality gets assigned to the alternative hypothesis, HA. Alright, so in the two-step process, the first thing you do is just read the claim, write it down, and then write the opposite of that claim. Then, looking at those two statements, you decide which one has equality, that one becomes the null, whichever one doesn't have equality is the alternative. Here's the second one. The mean GPA of students in American college is 2.0. Alright, so in this case we're talking about a mean, so I'll use mu for our symbol. So the claim is that mu equals 2.0, right? It says that the mean is 2.0. That's is equivalent to an equals. So we have the claim is mu equals 2.0. The opposite of that would be mu is not equal to 2.0. So in those two statements, I see that we have an equality in the first one in the claim, and then we don't have any equality in the second. So this, once again, the null, it matches up with the claim, and the alternative matches up with the opposite. In this third example, on average, college students take less than 5 years to graduate from college. This statement is just a less than statement. So this time we have mu, because again we're talking about averages or means. Mu is less than 5, and the opposite of that would be that mu is greater than or equal to 5. Okay, again, here's that opportunity to make sure that you include everything that is opposite of the claim, including the equal to part. And then from this, we're going to notice that our null and our alternative are not in line with the claim and the opposite the same way they were for the first two examples. The statement that contains equality on this one is the opposite statement. So the null hypothesis, H0, is going to be mu is greater than or equal to 5. And then the alternative is that mu is less than 5. For this section, practice problems 1 through 10, nothing fancy, but these are just giving you some examples of identifying the null and the alternative, which is a really important skill and something that I would definitely practice. In section 2, we're going to talk about outcomes and type 1 and type 2 errors. This is something I'm going to cover, and I'm going to maybe ask you 1 or 2 questions about it, tops on the quiz, 1 or 2 questions, tops on the final. It's not something that I think is super valuable for you guys, but I'm including it because it's likely that your professors in college would consider this to be important and would make a big deal of it. Okay, especially if if their area of research is statistics, type 1 and type 2 errors are probably their cup of tea. So we'll go through this and make sure that we understand what the difference is between type 1 and type 2 errors. So here I have a table that basically gives us some different possible outcomes to one of these hypothesis tests. Okay, so let's look first at the column that says H0 is actually, or H0 is actually. So if H0 is actually true, then there's two possible outcomes, right? If we say do not reject the null, that would be the correct decision, okay? Because if the null is true, we wouldn't want to reject it, right? So if the null is true and we say do not reject, that's a correct outcome. That's good. On the other hand, say we either have made a sampling error or we did everything right, but we still got some weird values in our samples. It's possible that we might conclude that we reject the null hypothesis, even though the null hypothesis is actually true. And we call that a type 1 error. Okay, rejecting the null when the null is actually true is a type 1 error. In the last column there, what we're saying is the null hypothesis is actually false. So if you do not reject it when you should have rejected it, we call that a type 2 error. All right, and then finally, if the null is actually false and we reject it, that's good. That's a correct outcome. So there's two types of errors and two ways that we can have correct outcomes. So what we want to show is that there are four possibilities. Okay, we decided not to reject when H naught is true, which is correct. We can decide to reject when H is actually true. Okay, that's an incorrect decision, and that's a type 1 error. Okay, type 1 error that time because we rejected when the null is true. The third possibility is we decide not to reject, but the null is actually false, okay, which is again an incorrect decision. This time it's a type 2 error. And then finally, we could decide to reject when the null is actually false, which is again a correct decision. And we specifically call this, we should say the probability of this correct decision, we call that the power of the test. Okay, the power of the test is how likely we are to reject when the null is actually false. So let's talk a little bit more about probability of these errors. Each of the errors that will occur, type 1 and type 2, have a particular probability, and we have names for them, alpha and beta. Now we have seen alpha already. We call alpha our confidence level. All right, so if you have we call it not the confidence level, we call it the significance level. All right, significance level. So if the significance level is nice and small, then we have a pretty low probability of making a type 1 error. All right, so typically we deal with alphas of like 0.05 most of the time. All right, now beta on the other hand is the probability of a type 2 error. Okay, so the probability of not rejecting when we should have rejected, when the null was actually false. So we'd like for both of these, for alpha and beta, to be as small as we can get them, realistically. But we have to kind of balance how large a sample we want to take and how much data we need versus how low do we need alpha and beta to be. So, if you want alpha to be super duper low, 0.0001 or something, you'd have to take a really, really large sample. So we try to make these as small as we can, but we have to use reason, and common sense with deciding how big our samples need to be. So again, the power of the test, this is a term I mentioned on the last slide. The power of the test is 1 minus beta. So usually we want this to be as close to 1 as possible, right? If we want beta to be small, then that means that the power of the test, 1 minus beta, should be pretty close to 1. All right, so a couple of examples here where we're going to take it out of the context of just saying the null hypothesis is true or the null hypothesis is false. Here's the idea, okay? The null hypothesis in this case is that Frank's rock climbing equipment is safe. All right, so an example of a type 1 error would be that Frank thinks his rock climbing equipment may not be safe when in fact it really is safe. And the type 2 error would be that Frank thinks that his rock climbing gear may be safe when in fact it is not safe. So I frequently get the question in here at some point, which one's worse? Is it worse to make a type 1 error, or is it worse to make a type 2 error? Well, this example I think kind of gives you an idea of why the context would be important in answering that question. In the type 1 error, Frank thinks his rock climbing equipment may not be safe, but in fact it is safe. The worst case scenario there is Frank doesn't go rock climbing and lives to see another day, right? The downside is he didn't get to go rock climbing. With the type 2 error, the downside to that would be that, Frank does go rock climbing and he falls to his death because his gear isn't safe. So depending on the context, sometimes a type 1 error might be the really bad one that we want to be worried about. Other times the type 2 error might be the really bad thing that we want to worry about. So here's a little subtler example. Suppose that the null hypothesis is H0 is a patient is not sick. Okay, so the null hypothesis is a patient is not sick. A type 1 error would be that a doctor thinks the patient may not be sick when in fact the patient is sick. A type 2 error would be a doctor thinks the patient may be sick when in fact he is not sick. So which of these is worse? Well, this one is a little tougher to decide. It kind of depends on what the sickness is. All right, if a doctor thinks the patient's healthy, but in fact he's sick with something like, cancer, something or heart disease, something that could potentially take his life, well, then a type 1 error would be really bad. On the other hand, if a doctor thinks you have a particular disease and treats you for that disease with some medicine when you're not actually suffering from that disease, it's something else, then it's possible that some of the side effects from that medicine could cause problems. So both of these are actually probably bad. Which one is worse? It kind of depends on what the sickness is, right? So questions like these I think are kind of fun to ponder and maybe kind of get yourself thinking about the context and how the situation itself can dictate how important one of these two errors could be to someone. All right, homework for this one is 11 through 20, and I think you're gonna get the hang of it pretty quickly. You do have to practice a little bit in figuring out, all right, a type 1 means this and type 2 means that, but you guys will get it. So good luck on this. Let me know if you have any questions.